All right, guys, we're gonna go ahead and try this since I'm not gonna be here. This way you actually get some information for you. So this is kind of be rough. Just doing this on my iPad here, so kind of bear with me here. But for Wednesday, what you need to have in front of you, okay, you should have the copy of the new notes, and that should be on pink paper. I got those ready for you. That's one thing. The next thing you need, okay, is another wonderful copy of our periodic table. If you don't have one that's nice and clean, there are more pink periodic tables in the basket by my desk. Help yourself to what you need, okay? And then the sub should also pass you out the homework, which is this one. So you need 3 things in front of you. The homework, then you need the periodic table, and then you need the new notes, okay? So let's just go ahead, get started, see what we can do. Again, this is going to be kind of rough because I'm doing this on the fly, okay? So we're going to start off here with the term ion, and an ion is simply a charged atom, and it can be positive or it can be negative, okay? Next ion, a cation is an ion that has a positive charge, which is created by losing electrons, okay? All right, naming the actual cation, okay? So this is the naming rule for when you are doing cations, and they're super, super simple. All you do is the name of the element, and then you just tack on the word ion onto it. So calcium with a 2+, we're just going to name this calcium, and then ion. Again, I apologize for my handwriting. This is not the best video space that I have. I am in my kitchen right now, okay? Next one is anion. Anion is an ion that has a negative charge, which is caused by gaining electrons. These ones are a little more tricky, okay? Yes, we do the name of the element, but this time we tack on the special ending of IDE to it, and then we also add the term ion on the backside. Now, it's not nice and easy to say that chop off the last 3 letters and add IDE. That works for probably 70% of them. So it ends up to being what sounds the best, okay? So I've got 2 examples here. One is kind of the more traditional, and then the phosphorus is different. So chlorine with a 1- becomes the chlor, and then add the IDE ending, becomes the chloride ion. The phosphorus, this is one that we're not gonna kind of really do the last 3 letters. It becomes phosphide. And I spelled that wrong. Phosphide. Should be no O there. Okay? The other one that's kind of weird that always brings up questions is the iodine 1-. Okay? It sounds weird. It ends up to be iodide. That's how you pronounce it. Iodide ion. So that's another example. Okay? An element's ion can be predicted. Remember that everything wants to have 8 electrons in it, okay? So sodium, as we've become good to know, sodium has 1 dot. It needs to get 8. So we have to say, is it easier to gain 7 of them or to lose 1? And that is the winner, okay? Fluorine, 7 valence electrons, okay? Our lovely little fluorine right there. It's got 7, so then again, ask yourself, easier to gain 1 or to lose all 7? Well, it's going to gain, okay? So then what I want you to do, the next thing on your notes, okay, is that it actually says, center, okay, periodic table. So this is why I wanted to have a new periodic table for you. We're going to go ahead and we're going to make some marks on it as to what the charges are, okay? So a lovely periodic table. We're going to start with the very first column. As we know, all of those have one valence electron, one dot. So all of those elements in there, and I want you to mark this, form a positive 1 ion because they all lose 1. Next column over, and again, that includes hydrogen. So all of those, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Next column over, I have 2. Those are going to form 2. Okay, and yes, this includes all the way down. Okay, now for this section here, we're going to skip it for right now. We'll come back to it tomorrow. Okay, we're going to skip it there. All right, then we're going to move over here to our boron family. Now the thing is, it's not every single element, okay, which makes it a little bit more on the tricky side. And so, let's see if I can do this in a different color. I'm going to circle 3 elements, and they're the first 3 in that group. Boron, aluminum, and gallium. Those ones form a +3. Okay. Next column over, the carbon family. We're not going to do anything with that one. Again, everything wants 8 electrons. So half of 8 is 4, which is that middle column. So they do something different. So we're just going to ignore that one. Okay. Move over to the nitrogen family. Again, we're going to do 3. Nitrogen, phosphorus, and arsenic, which will now take on the -3 because they are with the 5 valence electrons. Okay. Next one over, we're going to do 4 elements on this one. Oxygen, sulfur, selenium, and tellurium. Those are going to be a -2. The halogens, okay, we're going to include all of those halogens except for that UU1. So fluorine, chlorine, bromine, iodine, and astatine, those are all a -1. And then our noble gases are selfish and they don't want to do anything, so they're a big fat 0 all the way down. Okay, so that's your periodic table. So let's head back to the notes. Ionic bonds. Okay, what do you think happens when an anion and a cation are placed together? Okay, so again, that means we have a negative and we also have a positive. So when we put those together, most of you are going to say that they balance out, which is what exactly they do. More technical, okay, is that they transfer electrons. Okay. Ionic bond, the electronic or electric force of attraction between 2 oppositely charged ions. So you gotta have a positive and you gotta have a negative. Okay. Ionic compound, any compound that is composed of oppositely charged ions. I want you to write here as well as made up of a metal and non-metal. That's going to become key. Anytime you have electrons transferring, you've got to have both the positive and negative. The positive comes from the metal, the negative comes from the non-metal, okay? This statement, the next one for all ionic charges, positive and negative charges must. This is the reason why I put this into 3 asterisks. If you don't quite get this, probably the rest of the unit is going to be difficult for you. Whenever you have a positive and negative charge, the charges must equal 0. If they don't, the formula is wrong. It's got to have that. All right, next thing, actually doing some work with this, okay? The rule, so what we're going to be focusing on is naming. Another term that's used more by chemists is nomenclature. So that's what we're going to be doing. We're going to write names, and then we're going to write the formula. So writing names and also writing the formula, okay? And again, when we write formulas, big thing, 0, okay? All right, so now where it says rule with your dash, and it looks like there should be something, this is your rule, okay? A metal with a non-metal, and that non-metal gets that magic IDE, okay, which is what we just did on the first page, okay? This lovely IDE, okay, that's what we're doing again, okay? So that's nothing new with that, okay? So metals in group 1 or 2, and aluminum. So those are the only ones that follow this rule, okay? So you're looking on your periodic table, okay? You're looking for the elements in group 1 and then also group 2, but then also little lonely hydrogen, or not hydrogen, aluminum over there, okay? So let's get this rolling. And then when we're done with this page, we're done, okay? Another big thing, the metal is always listed first, and then again the next thing is that your charges have to equal 0. Okay, so 2 big things. Metals first, charges 0. Okay. So here's what we got. We got sodium and we've got chlorine. Okay. Again, what these columns are, okay? This is going to be our formula for the first column, and then the name afterwards, okay? So again, it all boils down to getting a 0 charge, okay? So when I look at these, okay, I have a positive, I have a 1 positive, and I have a -1 positive minus negative equals 0, so we're good to go. We don't have to add any sodiums or any extra chlorines to make it 0. So this is simply going to be NaCl. Simple as that, okay? And then the name, the rule is the metal always goes first, okay? So we're dealing with sodium, okay? And then the non-metal gets that IDE ending. Chloride. So that's how it works. That's why we call it sodium chloride. And I wanted to start with that example because it's something that you already know, okay? Now, next thing, okay? I have a +3, but I only have a -1. So a +3 minus 1, we're looking at 2. We're not looking at 0. So what we need to do, we need to have a total of 3 minus to balance out that 3 plus. 3 plus minus 3, there we go for our 0. But I can't split something in half, okay? So what I'm going to do is I'm going to add 2 more chlorines. And now if you take a look, we've got our 3 plus, but then we have -1, -1, -1, gives us a -3. Now we're good to go. And so our formula then is still going to be just Al, but now for the chlorine, we have a 3. Naming them just the same. Aluminum, and then the chloride. So, aluminum chloride. So those are a few examples. Okay. Write the name for the following compounds. I'm going to do this really quick. I think I'm going to do it in my pen. See if I can make this a little on better here. We're dealing with sodium fluoride. Oops, sorry, you can't see that, huh? Next one. Potassium oxide. Beryllium nitride. Okay, I know I'm whizzing through these really quickly, but I want to get these examples here for you. Potassium, there's the iodide, okay? I'm going to bump down here. Cesium sulfide, potassium sulfide in the middle, strontium sulfide over here, oxide, and potassium. Oh, sorry, you can't see. Potassium chloride. Okay, last thing, formulas. Okay, now when I write formulas, okay, because we all have to do that whole charge thing is equal to 0. Above each of the elements, I write the charge. Okay, so sodium, go back to your periodic table to figure out the charge. Okay, and sodium is hanging over here with the alkali metals. It's got a +1. So that's what you should do to figure out the formulas. Go back to that. Okay. So sodium bromide, we're looking at +1, -1, so that's already 0. And ABR. Magnesium is a +2. Iodine is a -1. Uh-oh, we're not at 0. We're going to have another -1 there. MgI2. Strontium, +2, -2. Make them 0 already. Strontium, oxide, SRO. Calcium phosphide, calcium's a +2. Phosphorus is a -3. Think of, this is the one that usually causes problems. Think about what is the common number between 2 and 3, okay? And you should say something like 6, okay? That's a 6. And so you have to ask yourself, what do I have to multiply 2 to get to 6? What do I multiply 3 to get to 6, okay? Which is going to make this Ca3P2. Aluminum is a +3. Nitrogen is a -3. ALN. Barium nitride. Nitrogen is a -3. Barium's a +2. Ba3 and 2. +1, -2. Li2O. And lastly, potassium +1, phosphorus -3, K3P. Now, I know that's fast, okay, but at least you have somewhat of an idea. So now, go to that homework assignment. I'm going to show you how to do number 1, and then I'm going to set you on your merry way, okay? So last thing here. Here's our homework for today, okay, and we're filling this in. Remember, cations are the positive charge. I should make that a parenthesis. Cations are the positive, anions are the negative. So, sodium, go to the periodic table. We know that sodium is a +1. Oxygen from the periodic table for the anion is a -2. Formula, Na2O. So that's how you do that one. The bottom half is the exact same thing, only what's happened is the metal for these ones is not always listed first. There are some metals hidden in that second part. So for this bottom part, check your periodic table. Which one of the elements is the metal? Whichever one that is, that one goes first, okay? So go ahead, good luck. I'll be back on Monday and we can talk about what's going on, and we'll take our stuff from there. Good luck, have a good day.